Welcome to our first session on network music performance. It looks like the first presenters, or the presenters of our first lecture today are missing, Jonathan Bell and Aaron Wyatt. I hope that they'll show up within the next minute or so. Otherwise, I would ask Lindsay Vickery to start.
Jonathan is going to start.
Okay. I don't see, there he is. Okay, great. Okay. All right, Jonathan, is Aaron around? Will he be around? Jonathan?
Sorry, who's around?
Aaron going to be around? Your co-presenter or co-author?
Actually, I don't think so, no.
Okay, so then I will just greet you. I'm very enthused to welcome Jonathan Bell. He is been a friend for a long time. He's doing very interesting work, and he is not, a novice to network music performance. He will today present a paper which he co-wrote with Aaron Wyatt, also a friend of mine from Monash University. And the title of his presentation is Common Ground, Music and Movement Directed by a Raspberry Pi.
Can you see my screen? No, it looks like no.
Yeah, absolutely.
Oh, right.
Yeah, perfect.
Okay. Well, as Georg just said, my name is Jonathan Bell. I'm a composer, and I'll be co-organizing TENOR at Prism CNRS next year in Marseille. I'm presenting two papers today. The first one mainly deals with computer-aided composition. The one I'll present this afternoon deals more specifically with the topic of the day, networked performance. Common Ground is also the title of the piece which you'll hear tonight as part of the remote choir concert at 7 p.m. In retrospect, last year was for me an important moment where I was resident artist at French Academy in Madrid. In terms of music tech and notation, I've had a lot of time to explore new territories, but I could also go deeper into tools which I already knew quite well, namely Bach and SmartVox for choral performances, which are indeed networked performances. Common Ground, the title of the piece is in fact the name of an installation by Keke Vilabelda, Spanish artist, in which the performance took place. He created this beautiful immersive space with salt on the ground, paintings and videos on the walls. I've chosen a passage where you can clearly see also the choreographic element of that piece that we did with in score. On the right-hand side, you can see the choreography. A lot of this project is about Australian European antipodes, I find. We worked in Spain with the set and costume designers, knowing that none of us could really attend physically the performance since it was at the other side of the globe. Those pieces extensively use an idea I took from Ben Curry, an Australian student of Georg Hajdu. So this idea of head-mounted displays. I'd like to thank the Australians here, Kat Hope, Judith Dotworth, and Aaron Wyatt. Aaron, who's co-author on this paper, he managed to, the score distribution and the update of the scores on the Raspberry Pi embedded server which, so to speak, directed or conducted the piece. Now to observe a bit of the compositional aspects, the domain here obviously is technology for notation, but perhaps for this paper only, it's really about CAC, computer-aided composition. I'll talk a bit about Bach, which situates itself within that Lisp-based programs tradition, softwares like Patchwork, OpenMusic, PWTL. And I have two topics here. The first one is about the new Bach.eval object and its evaluation language for LLL, followed by a few examples of code and their application to choral music. Then I'll present some linkage with Contimbre, where I might have been influenced by Georg Hajdu and Max Core's playback support for Contimbre. So the first point in this presentation consists in discussing the Max paradigm for computer-aided composition when dealing with symbolic notation. I think what I'll say here for notation in some ways relates to St. Matt's ODOT or INECAM's FTM library about the simple idea to sometimes do things outside of Max. I recommend the author's articles related to the topic, but I will exemplify those problems in my own practice, so perhaps on a more user/practical level. To do so, we need to recall that in Bach, the data structure, LLL, consists of nested lists in a manner inspired by traditional CAC softwares. These lists can be represented as a tree. Each time you go further down the tree, you add a level of parentheses. So like you have add note in MaxCore, in Bach, you have the add core command. So the straightforward way to compose in Bach consists in adding notes on the score or formatting add chord messages of different kinds with specific onset, pitch, duration, velocity, and all the slot information on the right, bottom right. I'm here trying to format one of those add chord messages in Max. At the top, I'm wrapping and appending lists together. So the yellow object, like Bach.wrap, adds a level of parentheses around the list. The Bach.append appends lists together. At the bottom, you can see firing an add chord message will output the list stored to the right. But unfortunately, formatting complex lists in this way can be cumbersome and error-prone. And this is where the Bell language comes in. Well, just to let you know, it has nothing to do with my name. But so the Bell language, mainly exposed to Max with the Bach.eval object, makes the construction of Lisp inherited parenthesis structures much easier to write than with the data flow Bach.wrap system. This new way of formatting messages made it a lot easier for me, for instance, to build a composer UI which generates polyphony. This patch mainly controls if the singers sing together, if they start together, if they finish together, if they sing at the same speed, etc. I will now show a queuing system allowing for the singer to hear what comes next, recalling the performer with his/her next phrase so that he feels comfortable with text as well as intonation. Here are all the variables capitalized at the top. By iterating on each voice of the score and comparing notes, each note 2 by 2, I'm trying to identify the distance in milliseconds between one note and the following on the score. So onset 1 is the value of the first note. Durée 1 is the duration of the first note. Sorry, you'll notice I've had some little problems with my PowerPoint. Sorry about that. From which I get final 1, the end of the note. So here, for instance, the name écart 1, distance 1, is displayed in yellow in small because the difference between onset 2 and final 1 is small. Here, on the contrary, the distance is larger. However, still too short to sneak in a cue for the singer. Here, there's plenty of time. So in the first half, we can copy the singer's line and paste it to the cue line. And it needs to start as late as possible. So according to the length of the phrase and some simple math, we can deduce that the cue will need to start at onset 46 seconds. When the pause is short, the cue needs to be provided as soon as possible. So here's how it's implemented in Bell. If we have enough time, then we paste the cue just before the next phrase. If, on the other hand, the singer has only a short rest, we paste the cue as soon as the previous phrase finishes. Yes, sorry.
So now to give a quick overview of what I do with it, well, we just saw the very tonal baby trompetero passage. In general, however, the harmony is more driven by spectral techniques than that. In this particular,
this short extract I find funny. It reminds me of Gandalf in Lord of the Ring. I think we should do this with children, not adults. You saw the singers were head-mounted displays, which is something I wrote about at NIME and TENOR 2019. Well, we've done some attempts with Dominique Faubert installing a native in-score application, forwarding to those glasses. You can see messages received from another in-score instance on a computer. David Kimboyle for AR notation is a good reference. As well as Giovanni Santini, who's also presenting at TENOR this year. In Common Ground, the polyphony is built on the top of synthesized sound, realized with the synthesis toolkit via Percolate or HfMT filtered FM spectra, like in this example. Would like to conclude with instrumental writing and the linkage with the Contimbre library, used in combination with Dada and Mobu. The idea here was to explore the navigation within a multi-dimensional space and thus try, well, really it's an attempt, try and approach domains like machine learning and AI.
the goal is to interpolate between closed presets. For instance, here 2 points have both low dynamics and high register. So register or tessitura is constant, high, as well as dynamics, low. And here the music will go slower and slower. You notice towards the end a harmonic shift as well as a change in instrumental writing. More notes and the flute. This one is pretty self-explanatory, going from low to high register, forte to pianissimo, and ritardando. in those?
Well, I went a bit quick. I was nervous. So I hope you've both enjoyed the vocal and instrumental things. And thank you very much.
Thank you, Jonathan Bell. That was amazing. This was actually material, I suppose, for 3 or 4 lectures. I would like to learn more about this. Very, very condensed, and I'm pretty sure that the audience is going to have tons of questions. So, please ask your questions now. You can also use the chat window. Well, if no one has any questions, maybe you can still add something to your presentation.
Okay. Well, I'll reshare my screen then. And, well, I'm sure you have questions, Georg. The time I do this, I will.
Let me see. So we saw a number of videos and so in various locations. So what wasn't entirely clear to me is the nature of the network performance between those locations. Particularly, we once saw a space, a gallery space with these people in these suits, and then hazmat, I guess it's called, suits, and then we saw other spaces where people had like costumes on with head-mounted displays. So that wasn't entirely clear to me, but I suppose you can probably elaborate a little bit on that, how these different performances were set up.
Very great, thank you. Actually, that's not very clear indeed in the presentation. So it's, well, obviously it's part of that network performance realm, but within that realm, I read once I forgot the name of that book, Network Performance, by an Italian guy who saw that those local network performances, and this is what happens here. It's over Wi-Fi, not the internet.
Okay.
They're all linked to the same local Wi-Fi, and in both pieces, yes, they were on head-mounted display. This score. I didn't elaborate so much on that because actually I'm going to talk about it in the next paper. That's
excellent, excellent. So we're happy that you'll be presenting twice. There's a question by Lindsay Vickery. Have you noticed? Yeah.
Oh yes. No, it's not. It's, well, I mean, it's recorded in real time, but it's our interface, is it controlled in real time? And well, yes, I mean, because I just showed a video of one time when it was improvising, I'm telling it's not real time, but yeah, so the Mubu was, the idea was, I don't think I really used the whole potential of Mubu. It was really as a sort of 11 tracks of automation, like I could have done in a DAW, really. But, so it's 11 automation of the register, of the dynamics, of different playing techniques. Is it more noisy? Is it more like this, more like that? To be honest, I think I went a bit far in formalization. I feel more confident with the vocal technique, the vocal music, which is in some ways more intuitive. I mean, it worked. I was very happy I did this, and I had a lot of time for it, but I'm not sure this is the way I'll compose in the future. It's
okay. Yeah, sorry, we're a little pressed for time. So there's one last question by Slavko Zagorodz.
Yeah, hi, Jonathan. So you mentioned that you used cues for singers, and it proved to be a little bit problematic for spacing. But I was just wondering if they can see the score in those displays. Why do they need cues?
Yeah, actually, it's true. They see the score just like this. It's not real augmented reality yet. And why did well? It's really something I've been doing for a long time. My thesis was called audio scores, and it's really I feel like a singer on stage is confident if he just knows what he has to do. And in terms of microtonality as well, it's very you don't think about it and
Right.
you just do the pitch.
Yeah,
But it's a bit redundant.
pitching, yeah.
I agree.
thank you. Thank you. I think we need to move on. The next speaker is also a friend of mine, Lindsay Vickery from Australia, Perth to be precise. And his paper is going to be on notational strategies for integrating live performers with complex sounds and environments. So please welcome Lindsay Vickery.
Lindsay, we can't hear you yet. I don't know if you are speaking, but looks like you're muted.
There. All right, I'll even turn the video on. Ta-da. Welcome to
Yay.
Perth, Australia. Okay, so let's go. So the paper discusses strategies to allow for instrumental performers to emulate and interact with complex sounds and environments through visualization and music notation. And it discusses just two categories of works. One's involving animal sounds and one's involving environments of different kinds. And the kinds of strategies that I'm going to talk about are score preparation, which involves sometimes processing the field recordings or audio beforehand. I quite often use Eric Lyon's FFT's objects, maybe in particular Thresh and Resent, which I love. I built some software called Lyrebird, which there's a paper about from the ACMC, I think the Australasian Computer Music Conference from 4 or 5 years ago, which basically creates a real-time spectrogram colored according to timbral brightness and some other things. I'm going to talk a little bit about scale because these are proportional notation scrolling scores. So scale is important in terms of being able to read it. Use of grids and not use of grids in order to do transcriptions. I'm going to talk about just two types of transcription directly from a spectrogram, which is what most of these pieces use, but also transcriptions from topography. And I'm going to briefly talk about the portability of this setup with the decibel score player and Bluetooth speakers, using a laptop as the network. The scores were all assembled in Illustrator and they're all performed using the decibel score player. Okay, so the two works described in the paper were the first two works of a project to compositionally interact with sounds of Australian fauna. Since that time, there have been two further works. I'm just adding them there for completeness, but they're not discussed in the paper, so I'll just move along. Kurui for bass clarinet, piano, melodica, percussion. The title is the name in the Gubi language from southeastern Queensland for the Australian possum. Well, there's actually a number of different possums, but I think that it refers to this one, the Trichosaurus vulpicula. And it was built around transcriptions of 9 characteristic possum sounds, which were bridged by different interpretive digressions. So what I mean by that is interpretive digressions, compositions, sometimes also improvisations to suit the performance style of these two players. The reason I did that was deliberate in that I have done quite a number of direct, precise transcriptions of spectrograms, animal sounds and whatnot. And I was kind of interested in whether a piece could be made with no audio component, so a kind of proper chamber music work in that sense, just for 3 instruments, which kind of veered from the sort of faithful transcription or faithful-ish transcription to a more chamber music style of music performance. So this just shows you the proportions of these different sections. So the 9 transcriptions are shown in the colors, and the transgressions or the non-transcription parts are black. So as I said, there were kind of 9 sort of characteristic possum sounds. I'll just play some because they're pretty extreme. All right, we don't actually have them on my side of the country, or at least not in this, in the metropolitan area of Perth. So they're quite interesting to me. So I use the kind of rhythmic grunting sound of the possum to be essentially a kind of to determine a tempo for the whole work. So a grid was built that used those grunts as the kind of overall tempo of the work, which ends up being something like an equivalent of 125 BPM. And a vertical grid, which is built along so this is using Sonic Visualizer. So I don't know if that's too small for people to see, but the C's are in yellow, and the white lines are semitones, which allowed everything to be kind of plotted out. This is actually the very opening of the piece. It does use a cutaway score, so it actually does look exactly like that, not just not just a little bit like that. Okay, and there we go. Okay, so in addition to that, I developed these other secondary grids, which are different subdivisions of that crotch equals 125 style grid, to allow kind of diversions into other tempi, and to allow cross rhythms of various types, and polyrhythms and so on. The score also used transcriptions. This is another transcriptions involving gestural notations like this, and spectromorphological transcriptions like this. And so you can see how those match up with the spectrogram, I think, and cartoon convention symbols, as I've discussed in previous papers, to represent, for example, that the performer grabs a tree branch and shakes it in that piece. So this is just a little bit of that work. Okay, I'm worried we're going to run out of time, so I'm going to move on. But you might remember that we actually played it at the last tenor, the one in Monash, which was like 200 years ago. The second animal piece discussed here is wadang, which is the Wajak Noongar word. That's the local Perth, in fact, southwest area of Australia, Indigenous language. It's, I think, the largest Indigenous language group in Australia. The recordings were made at Murukata, which is like it's the principal park, which some of you may have come to if you came to the ICMC back in 2013. The Australian crow has a very distinct three-part call, which you'll hear in a second. But in addition to that, there was a baby crow in the place where I made the recording, which the baby crow made this very peculiar mewing sound. So this is not an instrumental work. It had a electronic part, which was, and a kind of very artificial type collage was created out of this work in 6 channels of audio. The FFT's object thresher was used to pull out some of the most important frequencies from the crow sounds, which were also pitch shifted. And anyway, so there was a lot of processing of these sounds, and also some of the large sections were processed through Resent to change the speed and phase of their audio bins. So as with Kurui, these are like 4 sections from different parts of the piece, just to give you an idea of how the transcription and how all these things fit together. Oh, sorry, one more thing. So I'm going to play in the recording I've made. There's just the electronic part, and then the electronic part in a live performance with the instruments. going to jump ahead again onto the environments pieces. So this piece, Rising Water, it basically had to use the same recording by Leah Barclay of Floodwaters Rising in Queensland, but it processed them in a number of different ways, swapping over the frequency and control, using the frequency data to control the amplitude and using the amplitude data to control the frequency, audio threshing as described before, and freezing of the frequency spectrum at specific points, as you can perhaps see in here. Oh, sorry, that blue line is not meant to be there. Anyway, and also using the Lyrebird software to create a kind of base around which these other components could be added. And so the changes which were created by the spectral freeze were used as the formal structures of formal components of the work. So each of those caused different kinds of notation to be used for the instruments to create a kind of eco-structural kind of overall structure of the work based on the actual contents of the original audio. In this piece, Wilson's Downfall, a topography of the area around the place where the recording was, where the performance was made, which is called Wilson's Downfall, was used. So these, the river and the tree line and of the main road that goes through this region were all just tracked using Illustrator. And then all of the features of the land were attached to each of those lines, each of those three principal lines. So this is a piece for 3 performers. If you recompress the work, this kind of summary of the color data from the map was stretched out according to the shapes of the river and the tree line and the road. And then, but when they're stretched out to kind of normal length, so that's 3 sections of this, you can see that they create kind of figures which were kind of notation-like, and a 1914 postage stamp from that time was added on top of it. These lines were also mapped in Max to control the spatialization of the 3 field recordings that were made in the area as well.
Okay, Lindsay.
Running out of time?
We're running out of time. We're actually over time now. Yeah, and so you also like maybe the presenters could always open their chat window so I can be in contact with them. And I think it's probably, if you want a Q&A section, or session, and we have now. Otherwise, we can continue until the next the turn of the next.
Yeah. Just the sort of most, I guess, last point here is that with the decibel score player, you can put different files in scores that are named the same thing. So you can, that way, have a bunch of iPads all networked together playing the same score, but playing different audio files. And if you use Bluetooth speakers, then that means that you can perform them anywhere in the middle of a lake, which is what we did for that piece. All right, I'll leave it there.
Okay, thank you very much for your highly relevant beautiful scores. And so any questions? Could you please mute your microphones? I'm hearing some background noises. Okay, so who would like to ask a question? Let me see. Please raise your hands if anyone wants to ask a question. Then maybe I would like to know more about the performances themselves. Lindsay, could you also talk a little bit about the when and how these pieces were performed and who the musicians were?
Okay, well, so this piece that you're looking at now, Nukenbar, is different to the other ones. It was part of a series called Limited Hangout in the Field. It's got its own website, so you can have a look at Limited Hangout in the Field. So I think it had 16 performers, so I can't remember, sort of an ad hoc group, but performed at night in the middle of this lake. So the other pieces were all so this was this Wilson, Stell, and Kurui were both created for Doubt as part of a residency that I did with them. And the others, so Wardong and Rising Water, I think that's it, were performed by Grey Wing, an ensemble of clarinet, harp, and electric guitar and flute.
Thank you very much. Thank you very much. Thank you. So the next speakers are Christian Klinkenberg and Lothar Felten. Someone should probably please mute your microphones. I'm hearing a lot of background noise. If you haven't already muted your mics. Okay, thank you very much. So the next presentation is by Christian Klinkenberg and Lothar Felten. And I'm quite acquainted with Christian's work, which has quite a bit of overlap with my own musical interests. I have served on his dissertation committee a couple of years ago. So welcome Christian Klinkenberg and Lothar Felten, and they will be presenting today on Autoconductor, synchronizing graphic scores, multi-channel sound, and video files.
Hello, my name is Christian Klinkenberg, and together with Lothar Felten, we are going to present Autoconductor. In 2017, the opera Das Kreuz der Verlobten was first performed. At that time, we didn't have a software solution for synchronizing video scores. We just had our video files, individual video files for each musician. The conductor just counted in and everybody had to press play on his computer. Of course, in this way, no synchronization was guaranteed. The following project was the leaf that hung but never grew. It was an interactive musical narrative. Here we had also video files for each musician and one score for the audience. This score was projected on a screen, so we had to find a software that synchronizes video with the scores. We found SyncPlay, but in the end the result was not sufficient. During the rehearsals and some performances we had delays of more than 2 seconds. Also for the following project we needed a video file for the audience because the twin brother of Gabriel should be always on screen and the actor should be on the scene. So we needed a solution for the synchronization. Some of the available solutions for graphic notation are Decibel Score Player, QuintetNet and SmartVox. Concerning the decibel score player, we didn't have the possibility to buy an iOS device for each musician. The second problem was that we couldn't find the possibility to integrate a synchronization for the video file, as we needed to synchronize the voice of the virtual actor on the screen with the actor on the scene. So I asked Lothar Felten to think about a software that allows a synchronization for HD video for the audience, including multi-channel audio. Next, the synchronized scores for the musicians, the light technicians, the director, conductor, and so on. So we needed, first of all, graphic notation for all. So that was always the 3/4 of the screen above, and the lower quarter was always used for a precise notation per instrument. And everything should run on a web browser, so everybody can use the computer or the smartphone or the tablet he owns. As I also wanted to use some passages that needed groove, I needed a click track for the drummer and for the conductor. Now Lothar Felten is going to describe the development of the software.
Just want to go quick over some of the technical design goals we had for this. Next slide, please. So for the client side, so whatever every musician or the conductor would have, the goal was to run it on whatever hardware gets brought along. So we support Windows, macOS, Linux, Android, iOS. We also didn't want to have an app or a program to install, and should be easy to use. We also wanted to use wired and wireless network support, because more and more of the portable devices especially don't provide any wired network access anymore. Basically, this is all a good reason to choose HTML5 and JavaScript. So the implementation was completely done for the client side on using HTML5, JavaScript, and for communication to the server, we use WebSockets. Next slide, please. For the server side, we had also a few design goals. It should be portable and low cost. Basically, everything should just run from a standard laptop and still support full HD video and multi-channel audio. Another point was it should be easy to use. Basically, you get at the venue, turn on your laptop, and you're almost completely set. So the implementation was done with a focus on available hardware and a lightweight implementation, so we make best use of the computing power we have. So the entire application is basically written in C++, using Qt libraries and the framework it provides us. The data gets sent to the client over a standard web server, and it's all running on Linux OS. Next slide, please. This is a test setup using 3 embedded systems. They're booting directly into a web browser. Here you see how when it starts, it shows a generic screen. It doesn't show much. You select the instrument and you get the appropriate score. And since the autoconductor in this case is already running, you immediately get to the right point into the score.
Like nowhere else, life happens in circles.
This is the server side. So basically, this is the control panel that's shown here.
Down the gullet. The gullet loses its edges. Down the gullet. Down the gullet. Down the gullet.
Of course, we have also the possibility to jump to certain passages or to move forward fast.
It's me.
As you can see, there's also the possibility to play the video slower or faster.
Of the brothers.
If you want to rehearse something with the ensemble, half tempo or something like that.
What was still a feeling? Crystals do not stand still.
surrounding the time crystals is broken down in the description that appeared in physical renewal letters. On this basis, researchers from both the University of Maryland and Harvard University
down the gullet loses its edges.
Here's another example of the instrumentalist's view. This instrumentalist has to play the red color, and above the notes I always wrote the cent deviations because it's microtonal.
Ach, Max, wer weiß, was die Natur uns vorsieht und was die Erde dreht. Ich weiß, ich will jetzt rasten.
In this example you see that the audience can also see sometimes the graphic notation, and I tried to plan the graphic notation in a way that it fits with the acting. In that way the graphic score gets a double sense, not only for the musicians but also for the audience, to create a part of the scene.
Die Gletscher der patagonischen Anden, die in feuchtgrüne Täler reichen.
Gabriel?
Lothar?
Yeah, next. Okay. This is just an instruction how to use it. Basically, you set up your laptop and your network router, which is a generic network router, and then you press play on the GUI, and it starts playing the video, and all the clients that connect are synchronized. Here's some implementation details. That's how it's set up. On the server, we see at the lower left end, this is basically just a web server presenting a single HTML slide and all the images. The client just connects to this one, and then afterwards, JavaScript opens a connection via web server to the Autoconductor itself. The Autoconductor itself has a small GUI, which has a tape transport control panel and takes care about synchronization of audio, video, and sends out all the synchronization information to the clients on the network. Next slide, please. On the client side, we see that there's only a browser being used. So the entire application is just a website. The JavaScript takes care of preloading all the images. That makes jumps quite fast and makes up the connection to the server using a WebSocket for the timing information. So it knows what slide it should show at which position. Next slide, please. So for ongoing development, we have currently triple HD video output for a new project of Christian. Then we will use 3 HD either screens or projectors, or the application doesn't really care. It's three times HD video output. We also will provide MIDI output to synchronize other applications. That could be either an application or a hardware device. Doesn't matter for the Autoconductor. And I also planned to support DMX. DMX is the protocol used for lighting control in venues. Basically, you can control the movement of lighting heads and the color of the lighting.
So don't forget to switch on your devices on Thursday, because then one piece will be performed. That's the Leaves the Tongue But Never Grew. It's a composition for interactive audience and musicians that play especially in microtonal mode, Poland peers. Are there any questions?
Okay, thank you very much, Christian and Lothar. This is amazing work and highly relevant. I saw that Rama Gottfried, who is also working in the same direction, has raised his hand, and he wants to ask a question. So Rama, please go ahead.
Hi, yes, congratulations. This is really great work. Thank you very much for your presentation. Really beautiful, and looking forward to the piece. I have just a small technical question. I was wondering about the synchronization method that you're using. I've been looking into something like this also for the DrawSocket platform that I've been developing. And I'm wondering, are you updating the synchronization continuously, or is it like, are you adjusting throughout the piece slightly the timing, or is it more at the beginning of the piece that you set the synchronization?
No, currently I'm really setting synchronization timestamps every 30 milliseconds. So basically there's a continuous flow of synchronization. This could be changed, but the network load is pretty low once the images are loaded. So I can afford basically to send out information, and it's really, really low overhead.
And there's no glitches or anything when there's updating the video or audio?
On the server side, not. Now, the three systems that were shown here are using a different resolution. They're not full HD screens, but I happen to have three of them. So they have some issues with scaling. But as soon as you run in full HD, it's almost fluent.
Great, thank you.
Any other questions? We still have a few more minutes.
I see Jonathan Bell has asked a question in the chat window.
The chat window. Okay, so Jonathan, you want to speak up, or shall I read this to you?
Sure. Well, I noticed Node.js and WebSockets often go hand in hand together. Have you considered using Node server-side?
Yeah, my background is embedded systems programming, so I tend to run small applications on small systems. So Node.js is, from my point of view, a bit overkill for this application. I'm really writing everything in C++, and it makes it also very low on CPU usage. So once the system is running, there's not much load. So Node.js would probably be also a valid approach to this. You can probably implement the same in Node.js, but for audio and video synchronization, I prefer to use C++ framework. I have not seen audio and video synchronization done with Node.js. Could be. So there's no reason to use Node.js or no reason to not use Node.js. It's just a choice I chose for C++ due to my background.
Great, thanks.
Okay, thank you. Other questions? Yeah,
I guess I have I'm curious about the interpretation instructions that were given to the performers from the notation. I guess, are there scores available online somewhere that we could, I'm curious about the instructions that you give to the performers. Maybe that's a longer topic, but I'm curious to learn more.
Yes, there is a publication, yes, Babel scores. There is the Glacier, the latest you can find. The others I didn't use yet, a publisher or something like that. But yeah, that's an interesting issue, of course. Not writing too much because I want the musicians to be very creative, and there are a lot of things that happens during the rehearsals and you can change them. But of course, there's also the compositional part. And of course, as we have the different videos, we have one common video, and then the lower part is one individual video for each musician. There are a lot of possibilities, information per instrument.
Thank you. I look forward to checking that out.
Thank you. I also have a question concerning the audience participation. Can you go over that a little bit? What exactly is the audience supposed to do?
I give it to Lothar.
Okay, that's for the 7 leaves. We set up a second network where anyone can connect using a smartphone or his PC to an open network and then start a website. And every user gets added to a queue, and always 7 users at the same time can join in and play. So when it's their turn, their smartphone will show a keypad with symbols, and you saw maybe the graphic notation from Christian. Now this was a different one. He used lots of colors, and if you see the color and the symbol, you can press the button and it will then send out, the server will then send out a MIDI message, and Christian will play a sample. So it's basically the audio stuff is his job. And if your time is up, there's a given time slot, a fixed time slot. The next user in the queue can play, and the other one gets added to the back of the queue and has to wait for his next turn. There are always 7 users playing, and I'm outputting 7 different channels of media audio.
Yes, in fact, we use symbols that you can recognize, and they have a button, and you can see there's a screen projection for everybody, for the audience, and so they can play together with them. They can play a score even without being able to read music. They just have to recognize the symbol and press it at the right time on the mobile phone. So they are interacting.
Okay, so well, why are you limiting this to 7 people?
That's Christian's choice. It's more a musical choice than the technical one.
Yes, it's of course, we have 7 musicians, and we have at the same time 7 players in the audience, and they turning, because I had that's also a score in 7 different colors, and every player in the audience has a color. Somebody is brown, the other one is yellow, and we have to make a limit, because otherwise we would have to use similar colors.
Okay.
And that would be difficult.
Understand. Sounds exciting. So I'm looking forward to that. This session is now coming to a closing, and there'll be a short break until 12. Let me see. I just need to look at the schedule.
12:30.
Here we have another session at 11:30.
Sorry, 11:30.
Right. So it's a paper presentation, theory and practice. So we'll have another 2 papers in about 13 minutes. So I'll see you soon. Thank you for presenting and attending.